This is Geetha from CSE Department, the Bharat Institute of Higher Education and Research. In this video, we are going to see the concepts of transport layer that comes under networking. First, we will see what's the role of transport layer. Before going that, we must know what are all the layers are there in the OSI reference model. We know that we have 7 layers under OSI reference model. Physical layer, data link layer, network layer, transport layer, presentation layer, application layer, session layers. So see here, this is here transport layer acts as a mediator between the lower level layers and upper level layers. In lower level layers, we are having data link, physical and network. In upper level layers, we are having presentation, session, and application. So this transport layer carries the data from the upper level layer, from the lower level layers to the upper level layers, as well as upper to the layer. This is the job of transport layer. Under transport layer, we have some protocols. Under each and every layer, there are a few protocols which is doing the job of the corresponding layer. Here we have the protocols such as UDP, TCP, and Sctp. User datagram protocol, transmission control protocol, and the stream control transmission protocol. These three are the important protocols under transport layer which are doing this transmission job. So before going to the protocols, we must know what is the procedure or what is needed basically for the transmission. There are two types of delivery: a host-to-host delivery and the process-to-process delivery. Host-to-host delivery, that is the transmission from one system to another system. Process-to-process delivery means a number of processes will be involved in under certain operation. When you are running a project, or few models will be combined, and then only we will get a final result. So every process should be run properly. It should be done properly without any errors or mistakes. So the process-to-process delivery must be done properly. So this transport layer is also responsible for process-to-process delivery. So here this network layer is, normally the network layer is responsible for delivery of datagrams. Here this transport layer look at the process-to-process delivery, whether it is has been done properly or not. So once it's perfect, then the job will be handed over to the protocols. First we will see TCP, that is Transmission Control Protocol. That is one of the most important protocols of the internet protocols. So why you are saying this is important? Because this is connection-oriented protocol, most reliable, and many number of clients or systems can be involved in this type of transmission. So here in the diagram, we are seeing the TCP connection establishment. That is three-way handshake. Three-way handshake means that is per transmission, three types of signals can be sent from the either from the client to server or from the server to client. So see here on the first we have the synchronization signal, that is then seq.client, that means sequence number. Seq means sequence number, that is sent from the client. So we have seq.client. Then from the server is sending acknowledgement of this SYN and the acknowledgement of this seq. Plus it's sending a signal from the server side. Again from the client side, acknowledgements of the signals received from the server and the next signal of the client, that is seq client plus 1. So upcoming signals will be numbered as 1 to 3 likewise. Okay. So at a time, the signals can be transmitted. That's what three-way hand. Three different types of signals. One is synchronization signal. Another one is sequence number. That is the next signals. The third one is ACK. Three different types of signals can be transmitted. This is the advantage of the TCP protocol. So here it's a reliable protocol because it will wait until the acknowledgement receives from the opposite side. Okay, it will not send the upcoming or next signal before receiving the acknowledgement signal. To wait for the acknowledgement, then it will send the acknowledgement signal. So the transmission will be reliable. So this is the receiver always sends either positive or negative acknowledgement. Yes, of course, if packet received properly, it will send the positive or the negative acknowledgement. Anyhow, it sends the acknowledgement for the previous packet which is transmitted from the sender to receiver or from the receiver to sender. Now the TCP ensures that the data reaches intended destination in the same order it was sent. The TCP is connection oriented. TCP requires that connection between two remote points to be established before sending actual data, and it provides error checking and a recovery mechanism. That is, data should be proper when it is transferred from one side to another side. And the data must be error-free. There should not be any errors in the data. There should not be any noisy data, missing data, redundant data, duplicate data. So that is responsible of the TCP. TCP will take care of that also. And it provides end-to-end communication. TCP provides flow control and quality of service. Means it provides good quality, and it operates in client-server point-to-point mode. That is both way, from client to server as well as from server to client. And the TCP provides full duplex server. Okay, it can perform roles of both receiver. That is, we know the meaning of full duplex. That is, both sender can send as well as receive. That is, sender can send request as well as response. The receiver can send request as well as response, not a single set transmission, both the side transmission. So this is the advantage of this TCP, and this is the TCP header. So total 32 bits gets split into source port 16 and destination port 16 bits, sequence number 32 bits, and acknowledgement number 32 bits. So separate bits are allocated for the sequence number, acknowledgement number, because in the previous slide we have seen each and every signal holds synchronization signal as well as sequence, right? As well as acknowledgement also. ACK, SCQ, SYN. These are the three different types of signals sent from the sent to the TCP. So we are having this separate bits allocated for the sequence and acknowledgement. So then fourth row we have see, left side 16 bits and right side 16 bits. Left side 16 bits allocated to header, reserved bits, code bits. If you add, we will get totally 16 bits. So right side 16 bits, totally 32 bits. And checksum 16 bits and outer 16 bits. This checksum is used to perform the error control and flow control operation. As we have seen already, this TCP is responsible for the error-free data. So if there is any error in the data, it has to be detected and corrected. For that, checksum is used. For that, 16 bits has been allocated. So these urgent 16 bits used as a buffer. That is, if there is any emergency of operations or transmission, there is bits are not free, means this urgent bits will be used just as these bits are acts as a buffer. And this header 4 bits and reserved for 6 bits means nothing but like flag bits, that ACK, push data, then synchronization bits. All these comes under these reserved bits, as well as code based on the operation. For set means 1, reset means 0, no operation means NOP. Likewise, it depends on the operation, the code may vary. So 1 bit is allocated to represent the code, to represent an alphabet, 1 bit, or numbers like 0 and 1, or NOP, no operation. So this is the header. For each and every protocol, header is important. In header itself, you can understand what are the operations can be done by the protocol, and what are all the features and what are all the parts are available in the protocol. So this is the contents given what we have seen already in the previous slide. And so the length is 20 to 60 bytes, and source port 16 bytes, destination port 16 bytes, sequence number 32, acknowledgement number 32, then data offset. That what we have seen under that header reserved, right? So in the previous slide we have header 4 bits, then reserved 6 bits, code 6 bits, then reserved bits. Reserved for future use and all set 0 by default. So this is the contents given in the TCP header. Next, UDP. UDP is a user datagram protocol. So what is the difference between TCP and UDP? Means UDP is a connectionless protocol. This is not reliable as TCP, and it will not support perfect transmission. That is, it will not wait for acknowledgement of the previous signal. It keep on sending the signals without waiting for the ACK signals. That's what it's called not reliable. It's not reliable, as well as it cannot be used for the transmission which involves number of servers or number of clients. Very few systems involved in a transmission, means those kind of transmissions can be supported by UDP, because this will not give any guarantee, or this will not wait for any kind of acknowledgements. This will not wait for any kind of signals. It simply keep on sending the request without waiting for any response. So this UDP is simplest transport layer communication protocol available of the TCP/IP protocol suite. It involves minimum amount of communication mechanism. It's said to be an unreliable transport protocol, but it uses IP services, which provides best effort delivery mechanism. As well as this does not generate any acknowledgement of packets received, and in turn, the sender does not wait for any acknowledgement. This is the major disadvantage of the UDP signal, but it is easier as it involves very few systems. It is easier when compared with the TCP. Then features. What are the features of UDP? UDP is used when acknowledgement of data does not hold any significance. It's a protocol used for data flowing, and it's suitable for query-based communication. It's not connection-oriented. It does not provide the congestion control mechanism. UDP does not guarantee ordered delivery of data. It's stateless. And the main difference between TCP and UDP, 2 points we have to remember. The first one, TCP is connection-oriented, UDP is connectionless, and TCP is reliable, UDP is not reliable. TCP can be implemented in n number of systems, and UDP can be implemented in fewer systems. These three are the major differences between TCP and UDP. So this UDP is used for simple request response communication when size of data is less, and hence there is very lesser concern about flow and error control. Why? Because very few systems are used here. Obviously, the possibility of data used also very less. So it is suitable protocol for multicasting, and UDP supports packet switching. This uses a routing information protocol. So routing information protocol means it's a protocol which maintains the routing table. Routing table means it holds the details, how many sender and receiver are client server details, and which client is free, which server is free, and the path between the client and the server, which route is clear, so which route is free from network traffic. All those details will be maintained by the routing table, and this routing table is handled by the RIP, that is routing information protocol. So before choosing the system, this UDP refer this routing table. As it uses very few system, it will refer the RIP, then it will chooses the system which has to be transmitted the data. UDP header we have. Header is very simple compared with the TCP header. It's not having much fields like TCP. It has very less fields. Only a header that holds 80 bits. Then it has length, checksum, source port, destination port. That's all. That is 8 bytes. So here we have source port, destination port, totally 32 bits. Each carries 2 bytes. We have seen here. Each carries 2 bytes. We'll see. Yes. Here they have mentioned as source byte is 2 bytes. 2 bytes means 2 into 8, 16 bits. So source port 16 bits, destination port 16 bits, length 16 bits, and checksum 16 bits. So length and checksum are the additional features that has to deal with the data when it is transmitting data from one place to another place. So when comparing TCP header, UDP header is very simple. It has only 4 parts: source and destination port, and length and checksum fields. That's it. So this, as we have seen in the last slide, source port and the destination port has 16 bits each. That is 2 bytes. And length. So it's used to identify the length of the data and checksum. When it wants to check with a problem or erroneous data, the checksum is the operation which is used for error detection and correction. So checksum has been allocated with 16 bits, that is 2 bytes. This is UDP header. Here this UDP port number fields are each 16 bits long. Therefore, range of port numbers defined from 0 to 65535. So port number 0 is reserved for this UDP. Next, we will move to the next one. That is Sctp. Sctp is the stream control transmission protocol. Stream control transmission protocol means it controls the transmission by streaming. Okay, it will allow X set of data has to be transmitted. It will not allow much transmission like TCP. That is the difference between Sctp and TCP. But it allows limited transaction, but not as UDP. It's reliable. Not as UDP. It's reliable. So it has the features of TCP, and also it works less, or it connects with very fewer systems like UDP. So it's nice between TCP and UDP. The main difference between TCP and Sctp is it deals with streams, set of data. So it's a connection-oriented protocol in computer networks which provides a full duplex association. Means both sides it works, transmitting multiple streams of data between 2 endpoints at the same time that have established a connection in a network. It is sometimes referred as next generation of TCP. One step advanced, we can say, like it has some advantages over TCP. So we can avoid the negative acknowledgements or some fault transactions through this Sctp. It's more reliable than TCP. Sctp makes it easier to support telephonic conversations on the internet as it's very reliable and avoids negative acknowledgements. It filters only the positive ACKs. A telephonic conversation requires a transmitting of voice along with other data at the same time on both sides. The Sctp protocol makes it easier to establish reliable connection. So what are the characteristics of Sctp? TCP supports multicast. Here this supports unicast with multiple properties. What are the properties? Here it's reliable transmission, message oriented and multi-homing. The first one, unicast with multiple properties. It's a point-to-point protocol which can use different ports to reach the end host. This is very important feature of Sctp. By achieving this point-to-point protocol, you can say that this Sctp offering a reliable transmission. Okay, because you can use different parts to reach the end host. Anyhow, it will reach the destination. It will reach the destination with the support of routing table also. The reliable transmission, it uses and checksums to detect the damaged, corrupted, discarded, duplicates, and reordered data. It is similar to TCP, but Sctp is more efficient when it comes to reordering the data because it uses streams. As it uses streams, definitely it will order the data rather than TCP. TCP doesn't care about ordering data and all. It concentrates on sending the data only by receiving the ACK. It concentrates on only ACK. But Sctp will take care of the ordered data. So it gives importance for the ordered data. It will send the data by streams. Message oriented, each message can be framed and we can keep order of data stream and tabs on the structure. For this in TCP, we need a different layer of abstraction. So the messages has to be delivered from the sender to receiver or the receiver to sender. As it is sent as a stream, the messages will be given periodically. So when one stream is completed, the message will be given. So it depends on the message oriented. Once the message is delivered, then it will move to the next stream. So Sctp depends on messages rather than RTC. Multi-homing means more than one host. So more systems. It can establish multiple connection paths between two endpoints and does not need to rely on the IP layer for resilience. So it concentrates on the multiple connections part. It will work with multiple systems. So it concentrates on more systems rather than rely on the IP layer. What are the advantages of Sctp? It's a full duplex connection, that is users can send and receive data simultaneously. It allows half closed connections. The very important point is it's full duplex connection. Very important point is it's a full duplex connection. That's what it's used in telephonic conversations. The messages boundaries are maintained and application doesn't have to split messages. So this is very important feature when compared with TCP. Whether TCP doesn't care about these messages boundaries and all, but Sctp look after the messages boundaries, that will maintain it. It will take care of the messages by not splitting the messages. It will send like a set of messages based on the streams. So it, I said that it lies between the TCP and UDP because it has the characteristics of both the TCP and UDP protocol. And does it rely on IP layer for the resilience of the paths? What are the disadvantages? It requires the changes in the transport stack on mode. If you couldn't send any streamings, it need the changes. Instead of sending single lines, it sends a set of data. So if it can't send any streamings, it needs the change. Whereas TCP, there is no issues like that. It keep on sending without depending on the mode of transport used, without depending on the transport change, it keep on sending. But Sctp need it. Sctp requires the changes in the transport stack on node. So this is the major disadvantage. And applications need to be modified to use Sctp instead of TCP UDP. So the applications need to be modified to handle multiple simultaneous streams. So these are the two drawbacks. The one is applications has to be modified. The another one is if it couldn't transfer any stream, it needs the change in the transport stack on node. The main responsibility of Sctp. So this is the very important point under Sctp. Rather than TCP and UDP, it performs one more job that is called congestion control. Congestion control means when there is a whenever there is a network traffic occurs or network congestion occurs, it will slow down the flow. So how it will do? It has a special feature of doing this. You will see Sctp congestion control is based on RFC 2581 with some minor modifications, and the congestion control is applied to the entire association, not individual streams. So how it will work, we will see in the upcoming slide. And Sctp maintain a separate control window, congestion window, CWNT. So this congestion window is used to maintain a traffic without congestion. It will maintain a free flow of data, and parameters for each peer destination addresses multi-home scenarios. As defined in RFC 2581, the transmission rate starts slowly at the beginning. That is called slow start phase. This is the important phase of Sctp. Based on the feedback provided by received selective acknowledgement. So based on this SAC only, it performs. SAC is particularly used only in this Sctp, not in other protocols such as TCP and UDP. It depends on the SAC. By using this SAC only, it will it comes to know whether there is traffic congestion or not, and it will slow down the process. It leads to slow start phase. Then after the slow start phase, Sctp enters the congestion avoidance phase. In case of congestion in network, Sctp immediately reverts back to the slow start phase. So we will see how it works in the upcoming diagram. Here, slow start. See, slow start has been given. Slow start means, so it start to send the streams, but if there is any network traffic, what to do? It will slow down its requests. It will slow down the request. So it will wait for some time. Then again, it will slowly send the request. Okay, it will reduce the timing. It will reduce the time interval. For 1 second, it will send number of signals, means it will just reduce the timing. So this is possible only by Sctp, because Sctp supports congestion control rather than TCP or UDP. So this in a diagram it's shown CWNT means control window. This control window is used to control the flow if there is any network traffic. So to avoid the network traffic, so this technique is used, that is called congestion avoidance. Congestion avoidance will be done with the support of slow start phase. In the previous slide we seen, right? Slow start phase. This slow start phase is used to support congestion avoidance. So it will slow start means it will reduce the time interval. So it will wait for more some 1 or 2 seconds, then it will send. So this timeout off, it may be timeout or it will retransmit. Okay, so if it is timeout, it will retransmit. Anyhow, it will check with the network traffic at the destination side. So this receiver window, RWNT means receiver side. So this control window and the receiver window, this will determine the amount of data. That is, if a number of data has been sent and it leads to congestion, means it will send n-1 data. So it will decide how much data can be reduced to avoid the network traffic. So this will be divided by the CWNT, that is RWNT receiver windows. So this CWNT and RWNT define two windows where the smaller of the two determines the maximum amount of data that has been sent. After the slow start phase, the control window is large so that the receiver window becomes the dominant window size. Once it is over, then the data rate or the amount of data will be increased based on the control window. If it is network is clear, it will keep on sending more data. So this is about Sctp. Next, we will see the difference between TCP and UDP. No difference, that's the comparison. So in the simple picture, we could identify the difference between TCP UDP. See, in TCP, we have handshake. As I told you, we have seen in the previous slides, it has 3 handshake. SYN, ACK, SUQ means sequence number. So it will send receive the signal sent is it comes under SON or SUQ. The data signal received from the receiver side comes under ACK. That's okay. But in the UDP, we could see only two signals. Either it is request or it might be response, not waiting for ACK and all. As well as there is no procedure like that, only sender has to send request and receiver has to send response, not like that. Sender need to send request, it can send, or response, it can give. So whatever signals it need to send, it wish to send, it can send. So there is no restriction in the UDP side. That's not reliable, right? So from the receiver also, it keep on sending without waiting for any acknowledgement, as well as this sender side also. So this is the major difference between the TCP and UDP. So these all are the concepts about the transport layer. So just I want to recall the points. That is, transport layer is used as a mediator between the lower level layers to the upper level layers. Lower level layers has data link layer, physical layer, network layer. Upper level we have presentation, session, and application layer. So in a transport layer we have three protocols. Important protocols are UDP, TCP, Sctp. TCP is the very important, frequently used, connection-oriented, reliable. And also it supports process-to-process delivery, whether the process-to-process delivery is perfect or not. Okay, that will make sure by the TCP. TCP is responsible for three types of transmission, three types of signals, that is sequence, synchronization signal, and ACK. And the header, in header, we should concentrate on in every header of the protocols. Okay, each and every protocol will be having the header. The header first source and destination, then sequence, acknowledgement. These sequence acknowledgement, that is the second row, third row, varies depends upon the type of a protocol. In TCP, we have these signals, especially, so we have allocated these fields for the sequence and acknowledgement number. Then header, reserved, and code. If you add the left side, you will get 16, right side you will get 16, totally 32. This is the way we can remember this. And checksum is the important operation which is done by the TCP header, as well as urgent work, 16 bits allocated. The TCP header is very important under this topic. This is the explanation given for the header. Then UDP is connectionless and restless, not reliable, because without waiting for the acknowledgement, keep on sending the request without waiting for response. So this is UDP, applications of UDP. Then UDP header, not like TCP. UDP header is very simple. It has only source destination port, then two types of data. One is length, another one is text. That's it, UDP header. So each carries 2 bytes. 2 bits might be 16 bits that we have to note down. Then Sctp, stream control transmission protocol. This is like TCP. It will send protocol, that is data as a stream of data. So it's reliable as TCP, but it's not frequently used. It cannot send more signals like TCP, but somewhat advanced because it's more reliable than TCP. So it supports with reliable transmission, message oriented, and multi-homing. Full duplex is one of the advantage, and it maintains the messages. That is one of the advantage. Disadvantages is applications need to be modified to handle multiple simultaneous streams, as well as it requires the transport change. That is also a disadvantage. Then it supports congestion control. That is very important feature of Sctp. That means it maintains a separate phase, is called source start phase, to avoid the network traffic. Once it comes to know that there is a network traffic in the opposite side, it will slow down its process, slow down its sending process. That is the one important feature. So it will work with the CWND window. So that is the main feature of Sctp congestion control. It works with slow start phase that is given here in the slide. It works with a selective acknowledgement. Very selective acknowledgement will comes to know there is a traffic. Acknowledgements are very less. It comes to know there is a traffic. So it will